All right, everybody, we are in week 7 of MAT 205. This is the second half of the slides, so there's slides pages 16 to 24. And this is basically going to cover the empirical rule. So what is this rule? So this tells us that when data is normally distributed, and when you see those words normal distribution or normally distributed, I'm going to highlight that. Think about data that falls on like a curve, something like this. Okay, that's a normal distribution of data. All right, it starts low, peaks right here in the center, and then it comes back down again. Okay, so what does this rule tell us? It says that when you have data that's been identified as normally distributed, 68% of the values, well, the data values, will fall within one standard deviation of the mean. Okay, so that means if we start here at the dead center, right, here's your mean. All right, 68% will fall within one deviation. So I'm going to go up one and I'm going to go down one. Okay, so 34% of the data that you've collected that you may have identified as normal distributed data, that falls very close to the average. So we're going to just mark this out here. 34% on either side, and 34 plus 34 gives us that 68. Okay, so that's one standard deviation above or below. That's how far the data varies. Now we know that 95% fall within two standard deviations of the mean. Okay, let's come out two deviations. So up two, down two. Okay, well, if that's 68% and we need 95% to fall in between there, then we need 13.5% here and we need 13.5% here. So this is symmetrical. So what happens on the left has to happen on the right. So if you add 13 and a half and 34 and 34 and 13 and a half, you're going to get to that 95%. Now, most data, 95% of the data that you've identified as normally distributed will fall very close to that average. It's going to wander a little bit above. You might have data values below, but it's with 95% of the values will fall between -2 and +2 deviations from that average. Now, if you want to capture almost all of the data, you're going to have to go out 3 jumps or 3 deviations from the mean. So I'm going to go +3 here, and I'm going to go -3 here. So now we got to add in another 2.35% here and another 2.35% here. So now if you add up 2.35 and 13.5, 34, 34, 13.5, and 2.35, you should get 95% of your data falls within 3. So here's 3 deviations of the mean. Now, are you going to have some data that possibly falls outside of that? Sure, right? We don't have 100% of our data. That's 99.7 is close. But you're going to have data that are kind of considered unusual out here and over here. But for the most part, you'll capture 99.7% of the data within 1, 2, 3 deviations from the mean. Okay, what do we know about normal distribution? It's always symmetrical around the mean. It's got the same shape on both sides of the center. It's like a roller coaster that comes up, peaks, and comes back down. The mean, the median, and the mode are always equal to each other. So those are always going to be right there if you're working with normal distribution. It's unimodal, meaning there's only one mode here in the center, and the total area under the normal curve is equal to 1 or 100%. So if we add up this, we're going to get 99.7. Of course, you got a little bit out here in the tails. If you want to make it to be 100%, you got 0.15% here and 0.15% here. Okay, so this is what this looks like in a nicer fashion rather than my chicken scratch. Okay, so let me show you something that might help you think this through. So I call this the empirical rule and IQ scores. So in the world, we know that average IQ, so I'm going to put the average right here, is 100 points, okay? So we know our average is equal to 100 points. Now, not everybody scores 100 on the IQ test, right? There's a deviation. So the deviation, standard deviation, which you will have just learned how to calculate, is 10 points. Okay, so standard deviation is 10 points around this mean. Okay, so let's go ahead and make what I'm going to call a double or a set of parallel lines, we'll just call this right here. Okay, so on this first horizontal line, I'm going to call this 0, and I'm going to call that 100. That's the average IQ. Now we know that it can deviate 10 points. So you could have someone that scored 110, right? That would be one deviation up. You could have someone that scored 120. Let's add another 10 points. That'd be two deviations up. You could have someone that scored 130, right? That's three deviations that have data that's wandered to the right of the average. Okay. You also could have people that maybe scored a 90, right? So that's below the average by one jump, so 10 points. Let's come down another 10 points. Minus two deviations would give us a score of 80 points. And you could have somebody that scored down here at IQ of 70. All right, that is 10, 10, 10 points lower than the average. So you're three deviations away. So what do we know with this empirical rule? We know that if we were to test, let's just say we test 100 people, right? 34% would be between a 90 and 100 IQ. 34% would be between 100 and 110, or 68% would fall between a 90 and a 110 on the IQ score. That's 68%. That's what the empirical rule tells us. Now, if we come out another deviation, okay, come out two, now we have people that scored between 80 and 120. Well, that's 95% of the people, or 95 out of the 100 people that would score between an 80 and a 120. Then, of course, you have people, because we're going to go a little further, that have scored between a 70 and a 130, right? You're going to have data that falls between there. So I'm going to come below here. So the empirical rule tells us that 99.7% of people, right, almost 100 people out of the 100 people we tested will score between 70 and 130 on the IQ test. You still have people here, remember that 0.15%? Out in the tails that maybe score below 70 or above genius level. So we'll call that 0.15%. So you could still have people that score above or below, but just keep in mind for our purposes, we're basically going to stay within 68% or 95%. Let's come out another deviation, or 99.7%. So we'll add in that another 2.35%. So keep this chart close to you to help us answer the questions that are coming up here. So I'm going to use this chart because, of course, much nicer than my handwriting. All right, let's answer some questions. Hopefully this IQ thing helped you think that through a little bit. Okay, find the area. So everything under this curve is considered area or probability. So area or probability. That's underneath here. Remember, it's equal to 100% or one whole piece. Okay, so find the area under the standard normal curve that fall between a z-score. So z-scores are just deviations. So let's mark ours out between 0 and 2. All right, so we have 0, 1, 2, 3, and -1, -2, -3. I go ahead and write them all out, even though the problem's not asking us for all of this. It just wants to know what is the area between a z-score of 0, so these are our z-scores, between 0 and 2. Okay. All right, well, let's refer back to our chart. We know between 0 and 1, right? We got 34%. We come out a little further, we got 13.5%. So if we add 34 and 13.5, we should get the area between 0, a z-score of 0, and a z-score of 2. So let's go ahead and mark that out here. All right, so 34 plus 13.5 would be 47.5%. Okay. So that helps us answer that question. Now I'm going to put the next one up, and I want you to pause the video and then come back and check to see if we match. So here's the next one. Sorry, I have a orange cat walking across the across the screen here. All right, so here is your next one. Find the area under the standard normal curve that falls between the z-score of 0, oopsie, oops, and -2. So sketch it out. Sorry. Now, now I've got another cat in here. Um, sorry. Uh, hopefully this is not as distracting to you guys as it is to me. I'm gonna have to get them to move. Okay, listen here, cats. You do not want to do the empirical rule, I assure you. All right, back to business. So give that a try between z-score of 0 and -2. Okay, so pause the video and then come back. Okay, so if you're back, hopefully you figured out it was 47.5%, right? It just so happens that we went from 0 to -1 to -2 z-scores. So we went in the to the left or below average, right? But it's symmetrical, right? So the last problem we did 0 to 2, now we're doing 0 to -2. So we want this area here, all right? And if we use our little numbers that you'll have committed to memory, I promise, by the time you're done with this. You won't need the little cheater chart here. So it's 34% here and 13.5%. So if we add those together, hopefully you got 47.5. Okay. All right. So let's see if we can get you something maybe a little more challenging here. Let's see what's next. Okay, here's a question for you. Find the area under the standard normal curve to the right of z equals 1, expressed as a decimal, not as a percent. You know what? I wonder if the last one said the same thing. It did. It would be helpful, I guess, if I would read directions. Yep, same thing here. So I'm going back. When they say express as a decimal, they're going to want the 0.475. All right, so forgive me on that. I'm terrible at reading directions. So we'll call that 0.475. Express as a decimal. Yes, yes. And we'll do that here too. Okay, so I might mark that out so I don't forget. All right, so give this a whirl. Mark up your area curve and then figure out how much area under this curve falls to the right of a z-score of 1. So pause the video and then come back and see me. Okay, so if you're back, um, let's see if we match, right? So I have not completed this problem. I just sort of sketched it out, and hopefully you're using your area, your little blank templates to sketch things out for yourself too. Okay, so we know from here to here is 34%, right? And actually, if you figured it out, there's a couple different ways to go at this. Half of this curve is 50%, right? And if you need me to prove that to you, I'll show you here. So let's go back to this. All right, so we got the 0.15 plus the 2.35 plus the 13.5 plus the 34. So I guess it'd be helpful if I type this in correctly. 0.15 plus 2.35 plus 13.5 plus 34. There's our 50%. Okay. So yes, half of this is 50% and half is 50%. So that's one way to kind of tackle this, is to think about it in chunks of 50%. Okay, so if you wanted to, one way to tackle this is to say, all right, I know this whole thing is 100%. I know I can take out 50% here, and I can take out another 34% also here, right? So if you did 100 minus 50 minus 34, That's one way to kind of go at this thing. So looking at 16% or 0.16. Now, if that didn't occur to you, that's okay, because you can still go at it with what we already know. We know that this is 13.5%. We know this is 2.35%, and we know this is 0.15%. So you could add 13.5 plus 2.35 plus 0.15 and get 16% or 0.16. And I can do that on the calculator too, if that makes you feel better. 13.5 plus 2.35 plus 0.15. So 16%. Okay, let's see what else they got here for us. Oh, okay, find the area under the curve to the left of z equals 3 and express as a decimal, not as a percent. All right, so pause the video and come back and see me. Left of z equals 3. All right, so if you're back, I'm wondering how you went after this, okay? So one way is to do the tedious, adding up the 0.15, the 2.35, the 13.5, the 34, the 34, the 13.5, and the 2.35, okay? So that's one way to go at it. Or you know that this piece here is 0.15%, so you could take 100%, subtract out 0.15%. Let's see how that works here. So yes, my batteries are low. 100 minus 0.15, that should leave us with 99 let's see here, 99.85%. 99.85% of the area, and of course they want it as a decimal, so 0.9985 is to the left of z equals 3. Now, if that makes you uncomfortable, you can go old school and just add up everything you see, right? You got 0.15 plus the 2.35 plus the 13.5 plus the 34 plus the 34 plus the 13.5 plus the 2.35. And let's see if that gives us 99.85. It sure does. So however you want to skin that cat, totally up to you. All right, practice makes permanent. So we're going to keep going. We're going to practice some more. Practice doesn't make perfect, does not make perfect. It makes permanent. Okay, so practicing math looks like a sport is how we're going to get this permanently embedded in our brain. Okay, here we go. Find the area between z equals -1 and z equals 2. All right, give this a try. Come back and see me. Okay, so if you're back, hopefully you're sketching this out. I know those of you that are type A personalities are probably cringing at the fact that I'm just sketching this out really sloppily, but hopefully you can overlook that. So between -1 and 2, right? Let's see what we got here. So we know this is 34%. We know this is 34%. Then if we come out here, this is 13.5%. So hopefully you added 34 and 34 and 13.5. So 68 plus 13.5. So let's see what we get here. Yes. I will continue to use this calculator until it no longer turns on, and then I will change the batteries. So 34, 34, 13.5. I'm looking at 81.5%. So hopefully you got 81.5% and then change it to 0.815. Okay. That's between -1, below the average, and 2 deviations above. All right, so hopefully you're feeling pretty confident, but of course, they're going to switch things up on you, right, when you start to feel confident. It's how the Alex program makes me have a love-hate relationship with it. Okay, this time instead of asking us to find area, it says find the z-value. So now we're going to work backwards. So it says find the z-value to the right of the average so that 99.85% of the distribution lies to the left of it. Okay, so here's your mean, 0, right? And let's just put our deviations on here. -3 and 3. Okay. So I want you to think about this, come back here, pause the video, and then come back. Okay, so if you're back, when they want to know what z value, okay, these are our z values here. They want to know which one of these z values, which is to the right of the mean, would you pick in order to have 99.85% of the distribution lie to the left of it? All right, so if we go back to this, right, let's add up. So you get your 0.15. Let's go from the left. Plus the 2.35, plus the 13.5, plus the 34, plus the 34, plus the 13.5, plus 2.35. Okay, we're just going to leave out that 0.15. We have 99.85% of the data that falls to the left of this area 2.35 here and everything below. So it looks like it's going to be the z-score that is a 3. Okay, so we're looking for a z-score of 3. Oopsie. So z equals 3 would be our answer. Okay, I kind of did that quickly, so I'm going to just circle back. If you already feel good about this, keep moving. All right, so we know that here is 0.15%, 2.35%, 13.5%, 34%, 34%, 13.5%, and 2.35%. So one way to think about this is you could take 100% at the very beginning and subtract out 99.85%. And what does that give us? Well, that gives us that 0.15%. Well, we've seen that, right? That 0.15% lives in these tails that are very far away from average. They've wandered far away. All right. So they want the area, or they're telling us the area is 99.85%. They want to know what's the z value that corresponds with it. And so it's this 3 right here. All right. It's all of this area below is 99.85%. All right. I think we have one last problem. Okay. So once you kind of feel good about the empirical rule, they'll start throwing some story problems at you, or some action problems. All right, let's go to the movies. The average cost for 2 people to go to the movies is 18 bucks. Well, this must be really old because that is way more expensive nowadays. And it deviates $4. Okay, so give or take 4 bucks from that average. Assume the cost is normally distributed. As soon as you see the words normal distribution, you can break out this normal distribution, this area curve. Find the probability that at any given theater, the costs will be more than $22 for 2 people to go to the movie. All right, let's sketch this out. So we're going to make, let's do some parallel lines here. So we're going to have our z-scores here, or our standard deviations. And then we're going to have our money here for the movies, our money line. Okay, so we'll do our normal up 1, down 1, up 2, down 2, up 3, down 3. Okay, so standard deviation, z-scores, they don't care about the fact that we're going to the movies. So we have to add our information on here. All right, average cost is 18 bucks. That's going to go here. Give or take $4. All right, well, let's add 18 plus 4. Okay, so that's $22. Let's add another 4. 26. Add another 4. 32. Okay, you can also subtract 4. So what would that be? 14 bucks. 10 bucks. 6 bucks. All right. So let's make sure I can have this on the screen. -4, -$4, -$4. Okay. So let me just check this. 6 plus 10. 6 plus 4 is 10. 10 plus 4 is 14. 14 plus 4 is 18. 18 plus 4 is 22. Plus 4 is 26. Plus 4 is 32. So forgive me, I just wanted to double check this. 26 plus 4 is not 32, people. All right. Hopefully someone is screaming into their screen right now. Parcel, it is not 32. $26 plus 4 would give us 30 bucks. Okay, didn't even really need to go this far because the question said, what's the probability? And remember, underneath this curve is area, which is also probability. So sometimes people call this a probability curve. Area or probability curve. So find the probability that if you go to, for us here in Milford, Delaware, we would go to Milford Movies, that what's the chances that the cost would be more than $22 for us, for two people to go to the movies? So maybe I decide to take my husband on a date night, right? Okay, what's the chances, right? That it'd be more than $22? Well, let's just see. Well, we know, let's go back to this, right? We already know these percentages here. So we know this is 34%, but that's not included in more than $22. More than $22 is all of this. All right. So you got the 13.5%, you got the 2.35%, and then you got the 0.15%. So we're going to add up 13.5% plus 2.35% plus 0.15%. All right, and that's going to tell us the chances that I were to walk into Milford movie theaters and that it's going to cost more than $22 to buy tickets to the movies. All right, it's a pretty sizable chunk. Let's see what this comes up to be. So 13.5 plus 2.35 plus 0.15 is 16%. Okay, so let's see here. Do they tell us if it has to be in decimals or anything? Nope. Just find the probability. So the probability is 16% or 0.16. So there's a 16% chance that I would go to Milford movie theaters tonight with my husband, and we would buy two tickets, and that would cost more than $22 for us to go to the movies, given that the average cost is $18, give or take $4, and we're working with data that's normally distributed. Okay, hopefully this helped. If you're just seeing this for the first time, just give yourself some grace and some patience. This takes a little bit of practice, but once you get it, you will have it. Hopefully I haven't made any mistakes. If I have, um, just send me an email. All right, take care and good luck. Bye.